In this video, I will try to present my version of how it would be possible to make a space elevator. I know there are many ideas, but this time I present mine. I'll start by explaining all the steps from starting with the counterweight to reaching the surface of the Earth. I dare to say that Panama would be a good candidate for the location of this space elevator. This country offers many positive qualities that make this project viable. We are close to the geographical equator, we do not have earthquakes or hurricanes, we are the hub area of Latin America, and it is not a simple coincidence that we have here the Panama Canal. I have seen many videos about space elevators, and they all say that they will put a counterweight located 100,000 kilometers away from the surface of the Earth. But none tells you how this counterweight will be built. I have also seen that it has been suggested to capture an asteroid, take it out of its orbit and place it in the desired position and use it as a counterweight. Although this idea is not impossible, I consider that it is very difficult with the technology that humanity has today. In this example, let us first imagine the construction of a small spaceport located in Panama similar to the Kourou spaceport in French Guiana and a combined effort between the United States, Japan and Panama launching rockets similar to the Roten C9, but modified. Let's say, for example, if 300 of these, Roten C9 but modified, were launched into space, mounted on special rockets that take them to a low orbit of about 500 kilometers in space, and from there the Roten C9 continues its travel about 100,000 kilometers above Panama. Important note: the low-orbit rocket presented here is reusable. For the moment of re-entry, with the use of its propulsion plus the propeller system used in the Roten C9, tip jet propellers, they will provide the rocket with a smooth and precise re-entry back to the launch pad. Returning to this example, if every 3 days a modified Roten C9 is launched in each of the previously mentioned countries, and these modified Roten C9 launches travel to the indicated position over Panama at 100,000 kilometers, then assemble autonomously or remotely like huge Lego pieces as follows. Important note: I changed the color of the Roten C9 so that it stands out against the space background. First, these rockets will line up next to each other, and one of them will rotate 180 degrees on its axis and deploy its docking system. Important note: one of the main modifications will be that the propellers will be supplanted by a mechanical coupling extension system that will allow each of the Roten C9 to join and form a huge cubic counterweight. In this proposal we will use as an example of counterweight about 300 Roten C9 rockets that, according to Wikipedia, could carry almost 3 tons of cargo plus its weight without fuel, leaving around 20 to 25 tons for each Roten C9. When multiplied by the 300 rockets would give me more or less about 6,750 tons of counterweight. In the center of this counterweight of 300 or more Roten C9s, 4 variants of these rockets will be assembled. These red Roten C9s have a cable inside, as long as possible. In this example we will say that it is 500 kilometers long. At the end of this cable, there is a robot with multidirectional propulsion that detaches from its rocket of origin and will dock autonomously or remotely with the next 4 Roten C9 located 500 kilometers below. These 4 cables coming from the counterweight will be coupled autonomously or remotely with 4 rockets previously linked together, which are located 500 kilometers below. Important note: This process will be repeated for the next 64,000 kilometers. The platform will be located in a geosynchronous orbit, 64,000 kilometers below the counterweight and 36,000 kilometers above the Earth. I have tried to keep the design of the platform as functional and minimalist as possible, and the main purpose for which this platform was created is for spacecraft to dock to it to load or unload goods to and from space. It also has 2 walkways for spacecraft to dock that need to refuel and/or make repairs to spacecraft. This platform must be built simultaneously with the construction of the counterweight, with the difference that these ships will be manned by astronauts carrying pieces and parts to build this platform. Important note: the astronauts are to scale to give an idea of the dimensions. In this proposal, I consider that the use of the new generation of space shuttle, the XXS-3 Big Star, is opportune, since the amount of material required for the construction of the platform is astronomical. When the platform is finished, it will look like this, with 4 docking lanes for spacecraft, 2 with direct access to the loading and unloading area, and 2 dockings that will serve to supply fuel and repairs to the spacecraft, since the idea is that they remain in space as long as possible. Years. The construction of the road from the platform, kilometer 36,000, to the location of the cranes, kilometer 500, will be carried out thanks to a robotic machine that will assemble the pieces as they are delivered by the big stars to the previously built platform. And this is how it works: the components of the support structure and the magnetic rails will be delivered by the big stars on the platforms. On the platform, an autonomous robot will be in charge of unloading these supplies and taking them from the ship to the assembly machine. Description of the assembly robot. Inside the shell, the different robotic arms will take the pieces to form the supports of the magnetic rails and the support rings. Each section will be assembled by this robot, and when complete, the 4 huge pistons located at the end of the assembly robot will push this structure from kilometer 36,000 to kilometer 500. And these are the pieces that must be assembled by the robot: 4 magnetic rails that go from kilometer 36,000 to kilometer 500. 4 supports made of extremely resistant and at the same time light materials where the 4 magnetic rails will be attached, also ranging from kilometer 36,000 to kilometer 500. and rings that will support this entire structure will be separated from each other every 100 meters. And as the assembler robot assembles the parts, it will push them down, from 36,000 kilometers to 500 kilometers. If all goes according to plan, the end result will be a huge circular support 10 meters in diameter and hanging from 36,000 kilometers to 500 kilometers, as shown below. In this representation, if you remember the assembler robot, as it was building the support and the magnetic rails, it was also pushing the support bell, plus the custom cranes. Therefore, at the end of this long circular support of 10 meters in diameter and 36,000 kilometers long, hanging will be this support in the shape of a bell, made of lightweight but extremely resistant material, carbon fiber, similar or better. This support is about 100 meters long. And to this bell-shaped support, it has 4 huge custom cranes incorporated. According to Wikipedia, port cranes can load between 40 to 400 tons each and lift the load at a speed of over 50 kilometers per hour. So, the plan is to build 4 custom cranes that can load 700 tons each and lift the load at a speed of around 50 kilometers per hour. Meanwhile, on the platform, the escalator will be being assembled with the help of astronauts and the robots that will unload the pieces from the big star to the magnetic rail system. Important note: the climber must have its ends inside the rail system in order to function properly. For this point, it is imperative that the magnetic rails system is working at 100%. In this way it will be possible to send 2 special habitats that will house astronauts. Since the trip from the platform to kilometer 500 takes about 20 to 24 hours and 4 special weights that will be connected to the 4 cranes to be able to connect kilometer 500 with the surface of the Earth. Upon reaching kilometer 500, the 2 astronauts will leave their habitat and connect the 4 weights with cables over 500 kilometers long. In order to connect kilometer 500 with the surface of the Earth. Important note: these 4 weights must be aerodynamic and weigh between 10 and 20 tons and must descend at a maximum speed of 45 to 50 kilometers per hour. These weights will descend slowly as gravity attracts them, and upon reaching kilometer 100 their descent speed should not exceed 50 kilometers since the cranes should manage this speed. Important note: this operation should be done on a day with 0 wind. In this presentation, on the surface, a concrete floor with a ditch about 20 meters deep had previously to be built, and at the bottom of this ditch, 4 robust anchors will be located. Plus the platform where the cables coming from the 4 cranes One by one, the 4 cables coming from the cranes will be uncoupled from the 4 weights and welded to the platform anchors. The 4 main cables coming from the cranes will be welded in the 4 platform anchors, and in addition to this, 4 more thin cables will be added, which will serve as a guide when platform number 1 is finished. And this time, the 4 cranes will lift platform number 1 together with the 4 guide cables from kilometer 0 to kilometer 500 at a maximum speed of between 40 and 50 kilometers per hour. And upon reaching kilometer 500, the 4 guide cables must first be disassembled, and each one must pass through special holes located on platform number 1, to then be welded to the bell-shaped support. Since the entire system will work with electricity, on the platform, the robots, the lighting system, the climber, the cranes at kilometer 500, in conclusion, the entire system is electric. A system of solar panels will be placed very close to the platform, 36,000 kilometers. The solar panels measure 2 meters high by 1 wide. Each column measures 5 kilometers high, and there are 3 of them, and they will be located in the angle that is always facing the sun. Let's start on Earth. Both platforms, platform number 1 and number 2, are linked and secured with each other, waiting to be loaded with the special containers that will be taken to the main platform 36,000 kilometers above. Once loaded and ready to ascend, the cranes at kilometer 500 will begin lifting at a speed of between 40 and 50 kilometers per hour. Important note: if each crane will lift 700 tons and each cable weighs 1 ton per kilometer plus the weight of the platform plus the weight of the load, each container carries 15 tons. It gives us about 55 tons in. The 4 cranes together can lift up to 2,800 tons. After 10 hours or more, the elevators will gradually reduce the ascent speed until the platform reaches the top or end of the magnetic rail system and comes to a smooth and safe stop. Important note: the 4 guide cables that go from the surface to the bell-shaped support have 2 functions. The first is to prevent the platform from swinging with the wind, and second, when the platform travels from kilometer 500 to surface, with the help of the electric motors, the platform will descend quickly since there is not much gravity at that height. When both platforms, number 1 and number 2, reach the top or the end of the magnetic rail system, the climber will approach and engage with platform number 2, and both will use the electromagnetic rails to accelerate up to a maximum speed of 2,000 km per hour to be able to make the ascent to the platform in less than 24 hours. Important note: I forgot to mention that all cargo coming or going to the surface is strongly secured to platform number 2. Between the escalator and platform number 2 they will accelerate at a speed of between 1,500 and 2,000 km per hour in order to reach kilometer 36,000 in less than 24 hours. Upon reaching kilometer 36,000, the climber and platform number 2, the two robots that have direct access to load and unload the merchandise, will begin the process of unloading and placing the containers on the turntable. Each time a container is placed on the turntable, the container is secured and rotated 45 degrees to accommodate the next container, and the process is repeated until platform number 2 is unloaded. Important note: if everything goes according to plan, in the future the platform could be expanded from simple to a double level, so that 8 containers can be loaded in a single trip, since I am still within the weight limit what cranes can lift. After unloading the 8 containers from the escalator and secured on the turntable, we would have an image like this. 2 big stars being loaded with the containers coming from Earth into deep space, and 2 big stars waiting to unload the containers coming from deep space to Earth. Important note: the robots are autonomous or remote, so the presence of astronauts is only required to maintain the platform and/or solar panels. When the whole system is working at 100%, the construction of the jewel in the crown of this proposal, a rotating station, located on top of the counterweight, will proceed. For the construction of this rotating station, we will use the orange external tank of the Space Shuttle. And internal modifications will be made to make it a modern space station worthy of the 21st century. For the construction of this rotating space station, the section beam will first be sent where the ET will make its way. These pieces will be stacked safely and balanced on platform number 2 and sent to kilometer 100,000. How to send these huge pieces? Let's use as an example the ET external fuel tank. First, it will be located vertically, with 2 small multidirectional motors already installed at its ends. And it will be securely fastened to platform number 2, so that it will not move during its ascent to the main platform at kilometer 36,000. Important note: the diameter of the ET is 8.4 meters and the diameter in the section of the magnetic rail, kilometer 500 to kilometer 36,000, is 10 meters. Important note: upon reaching kilometer 500, the climber will be attached to the ET. Since adapted to the ET, there will be the fastener that platform number 2 uses to anchor itself to the climber. And from there, it will start accelerating at a speed of between 1,500 and 2,000 km per hour to reach kilometer 36,000 in less than 24 hours. Upon reaching the unloading level of the main platform, kilometer 36,000, with the visual help of astronauts, the piece will be disassembled. This is possible since the climber can climb up to 80 meters above the level of the platform. Between the robot and the climber hold the special piece, while platform number 2 descends a few meters. And as the climber descends, the robot will simultaneously pull the piece backwards in perfect synchrony, under the supervision of the astronauts. At some point, due to the angle, the robot and the climber will no longer be able to hold the piece. So a second and third robot using the turntable will come to help and finally carry the piece to the end. At this point, with the help of its two small multidirectional motors previously installed at its ends, the piece will take a course towards kilometer 100,000, while the two robots will return to their roads. As the pieces arrive, they will be assembled to form the rail along which the rotary station will move. It has a diameter of 250 meters, then its twin rail and its support or mooring cables. Then the rotating station. There are 6 external tanks on each rail plus their accesses from the center. Important note: this weight will also be added to the counterweight, which is made up of 300 Roton C9 plus the Roton C9 that go from kilometer 100,000 to the platform kilometer 36,000. More than 500, plus the rotating station. In the end, we would have 2 rotating stations with the capacity to easily accommodate about 120 astronauts with artificial gravity and with all the comforts and an interior design worthy of the 21st century. And also spacecraft that can transport 2 containers and carry materials from the 36,000-kilometer platform to projects located at other geosynchronous orbits such as solar farms, rotating station type L5 and many other projects close to Earth's orbit.